We're going to talk about compound inequalities, and compound inequalities, like the word compound, like especially in like science, is like a mix of two things. It's not just like a pure anything. It's one thing and another thing. So when we talk about compound inequalities, bless you, we're expecting to combine two things. So we're going to talk about these two words, a conjunction and a disjunction. So a conjunction, the technical definition here is that we're going to find the value of the variable for which both sentences are true. Meaning that we're going to end up with two different things that we are going to graph here, and we are going to see where both are true. Now here's what that means in plain English. Let's say you and I are talking about Netflix, and we're trying to talk about the best shows on Netflix. We will find a show eventually, hopefully, that we will agree on, right? We'll both be like, oh, I like this show. No, I don't like that show. Oh, Stranger Things? Oh, yeah, I like Stranger Things too. And be like, okay, we both agree on that. That is a conjunction. So we could say that that is an answer for both of us. It is something we both like on Netflix. It's something that's true for me, and it's something that's true for you. Whatever the show is, I don't care what you're using in your example. Whereas a disjunction is a value for a variable which at least one of the sentences is true. So let's say somebody is talking to you and I, a third person comes up and says, do either of you like cats? And I go, listen, I'm just not a cat person, sorry, it's nothing personal with cats, I don't hate them, I'm not a cat person. But you happen to love cats, and so you go, yeah, I love cats. Then somebody could say, yes, one of those two things likes cats. Like she likes cats, he likes cats, but not both of them. So when we're talking about a disjunction, it's something that is true for either one of them. If somebody said, do either one of those two people like cats? You could say yes. One of those two people like cats. So a conjunction has to be where both things agree. A disjunction can be where only one thing is true. And I will show you what that means here in just a second. So the first one is a conjunction. I'm going to do some color coding here because if not, you can get lost in these words and then the homework can be very confusing. A conjunction is true for both sentences. So watch as I graph x is greater than negative 2, and I'm going to use two different colors here to graph them, and x is less than 3. So let's talk about graphing x is greater than negative 2. How do I graph that on this line? Just the red part, x is greater than negative 2. Okay, we have an open circle on negative 2. Oop, I'm going to use the red one because I did that in red. Okay. Okay, the arrow is going to go to the right because x is greater than negative 2. So that's all of this area. That's the first part, and that is what is true for x is greater than negative 2. But there's another thing here. There's another part of this couple, and it says x is less than negative 3. How would I graph that part? Okay, open circle on 3. And then? And we're going to the left. So I just put it right underneath there so you can see both lines. Now if you notice, the blue line goes all the way to the left forever and ever and ever, and the red one goes all the way right forever and ever. But the only area that they agree, where they both have the exact same answers, is this area of conjunction, which is right here. So that area is true for both of them. So actually that's the area that would be the solution for here. So I'm going to do some erasing of lines here to show where the actual answer is, how this answer should look. So now that we've seen that, I'm going to erase something here. Oh, I forgot this is not notability. So if you notice, I just erased the parts that they didn't agree. Like that, these are the part where both of these couples agree. They're like, okay, we both have the same answers in that area. That would be the conjunction or the answer for both of them. If you notice, every answer in that area is greater than negative 2, but it's also less than negative 3. Everything in there is greater than negative 2 and less than negative 3. So notice, it's just that set of answers. A conjunction is like and. So when you think of a conjunction, it's two things that they agree upon. So I always like to put that little word and here because that's like, it has to be true for both of them. So I use that word and for conjunction. Where for a disjunction, I like to use the word or. It can be true for either one. So this one says, graph the solution set of the disjunction. So we're going to do the same thing here. We're going to graph x is less than or equal to negative 4, and then we'll graph x is greater than 1. So hook me up. Let's start with x is less than or equal to negative 4. How do I graph that? Okay. Closed circle because of this. If you're not sure why it's a closed circle, it's because of that line right there. And go to the left because x is less than negative 4. So that red line makes this true. Those are all the answers that'll be true. Anything that includes negative 4 or below or less than that will be okay. So now let's do the part where x is greater than 1. How do I do that part? Open circle. And then which direction? Right. To the right. Now, if you notice, this is an or statement. The answer can be in one spot or the other spot. So all of this is the answer, and all of this is the answer. So I'm not looking for where they overlap because they don't overlap. This is a disjunction. It can be the two separate parts. Anywhere where you see a line up there, a colored in line, then that is part of the answer. So we would leave it just like that, that we could say those are our answer. So far, so good? That's the difference between the two. The word and has to be, real quick, if you get stuck with this, this has to be the overlap. Whereas a disjunction does not have to be an overlap. They can overlap, but they don't have to. So let's try some sample problems. We're only going to do A, B, and C, and then we'll be done. So we're actually going to have a very quick day today. Now this is a little bit confusing because if you notice here, this is all one big statement, and there are a less than sign and a less than or equal sign. So everything is true that's always been true. We are still going to try to get x by itself, but we're going to leave x in the middle. So we're going to get everything away from x, but the one thing that's different is we usually say whatever you do to one side, you have to do to the other side. Well, now what's true is whatever you do to one side, you have to do to all sides. Everything has got to be fair. Because there's like three, I don't want to call it three sides. There's a middle, a left, and a right, correct? Here's the left, here's the middle, here's the right. Are we okay with that? Just that there's like three separate areas there? All right. So let's pretend I want to get x by itself. Focus in on that 2x plus 5. How am I going to start by getting x by itself? What should I do first? We all agree we should subtract 5. So whatever I do here, I don't just do it on one side. I have to do it on both sides. So what is 3 minus 5? Negative 2 is less than 2x, which is less than or equal to 15 minus 5? 10. Again, my focus is still on the x. I want to get x by itself. Where should I go next? Divide by 2. But I'm not just going to divide this by 2. I'm going to divide everything by 2. Negative 2 divided by 2 is negative 1, which is less than x, which is less than or equal to 10 divided by 2? 5. Now this is solved. Yes, ma'am? We're still going to flip everything if we divide by a negative. But here we did not. We didn't divide by a negative, so I didn't flip anything. But if we were going to divide by a negative, every symbol needs to be flipped. Yes, ma'am? Let me get there. We're actually not, because there's 3 different examples. We're not even done with the first one yet. So there's still more to this. So I need to graph this answer too, because it says graph the solution. And this can look a little bit hard to graph, but it's actually not. So here's what I'm going to do. I'm going to graph my line here. Let's just put our number line. Here is 0. I'm going to count by 2s here. 2, 4, 6, 8. Just means I can get more numbers in there. Negative 2, negative 4, negative 6, negative 8. Now you might look at this and be like, well, how do I graph negative 1 is less than x, which is less than negative 5? Well, check it out. Let's do this. Let's agree that there's 2 things going on here. One of them is right here. X has to be less than or equal to 5. That's one thing right there. So let's do that. I'm going to do that in red. How do I do just that part? X is less than or equal to 5. Okay, so notice I'm putting it in between 4 and 6. In which direction? To the left. That's that highlighted red part there. Yes, ma'am? When it doesn't have that equal on the bottom, yep. Now, the second part is right here. Bless you. I'm sorry, that was a delayed bless you. All right, so here's the problem with that. That says -1 is less than x. What do I hate about that? Like, what's bothering my soul about that right there? There's nothing wrong mathematically. It's all fine, whatever. I like the x on the left because it's always easy to graph when the x is on the left. So here's what I'm going to do. X is not on the left. I'm just going to put x on the left, and I'm going to put -1 on the right. But what happens to that symbol in the middle? It has to flip too. If I'm flipping sides, everything has to flip. So x is greater than -1. Now that is super easy to graph. That's way easier to graph. So let's do that. Well, if you don't, then you need to understand that these two things are going to graph exactly the same. They don't graph differently, where I think this is way harder to graph. It says -1 is less than x. We're not graphing to the left there. We need to show all the values of x. And right there, if we think about that for a minute, it's saying that x is greater than -1. Really, that statement reads -1 is less than x. But when we think about that, that means that x must be greater than -1. And x is the part that we're graphing. That's why I always flip it around, because when I graph, it makes it really clear. So how do I graph x is greater than -1? Open circle at -1, which is right here. So there's an open circle. And which direction? And we're going to the right. Now notice it didn't say and or, but I know that right here that x has to be a number that is greater than -1, and it has to be a number that is less than 5. So it is that area where they both agree right here. So notice right there, that's the area I'm looking at in the middle. So what I'm going to do is I'm going to take off the extra stuff here. I don't need this. Stand by. None of that. And none of this. We're looking for only the areas where they agree. I'm going to put my black line back in there.
How did you do that without your using the entire thing?
I'm using explain everything, not notability.
Oh,
So
no, but you can still do it for real?
So notice that it is still a red solid dot here, and it is still an open blue dot on the left, meaning it does not include -1, but it does include 5. Are we okay with how I graph that? Because we're going to do more examples of it, but that's the kind of things that you will have to do today. I split it into 2 parts, and it was way easier to understand that way. Let's try B. Now notice that word or in here, which means it can be true for either one. Anything that's true for either one of them is an answer. So let's talk about this one first. There's 2 separate equations here. The first one is 7 minus 2y is less than or equal to 1. What am I going to do first? Let's subtract 7. And then? Divide by -2. And here's the exact situation that you wanted, except for I don't have 2 things that I'm going to flip here. I just have 1. So we get y is greater than or equal to -6 divided by -2? A positive 3. So one of the things I'm going to be graphing is that. Why don't I just graph it right now? Let's get that out of the way. Yes, ma'am.
Why did you switch the sign?
Because I divided by a negative number. 3, 4, -1, -2, -3. I hope I have enough numbers here. I may not, because I haven't seen the other side yet. So here we go. Y is greater than or equal to 3. How do I graph that?
Close circle on the positive 3.
Good. And then? Which direction? Y is greater than or equal to 3. To the right. All the numbers that are greater than 3 are to the right. Okay, so there's part of the answer. But now we have to do this other part here, which is 3y plus 10 is less than 4 minus y. What should we do first?
Subtract 4. Or
I heard a couple different answers there. Which one?
you can subtract 10.
We can subtract 10. Now notice that I keep rewriting. I keep rewriting because this is what I expect on your homework, and I know I'm going to be obnoxious and keep saying this over and over. 4 minus 10 is -6 minus y. What's next?
Divide by
Not yet. Yes, ma'am.
You subtract 3y?
Not subtract y. Yeah, to get rid of a minus y, I need a plus y.
Oh, okay. Oh, because you didn't.
So we go 4y is less than negative 6. And then? Y divided by 2. So our goal is to get y by itself, right? So what should I divide by?
4.
By 4. I get what you're thinking. You're like, wait, this is not going to work out pretty. I'm not looking for pretty here. This is math. It's not always pretty. All right, negative 6 over 4. Now that is a fraction that can be reduced. Do we agree? What can it be reduced to? Negative 3 over 2. That is what we are going to graph. Y is less than negative 3 halves. If you're kind of like, wait, what? Where is negative 3 halves? Just do the division. Just go, okay, 2 goes into 3 once, 1 times 2. This is 1 and 1/2. Or y is less than 1.5, if that helps. No, sorry, negative 1.5. That was a negative. Y is less than negative 1.5. That's sometimes easier for people to see. So let's put our 1.5 right there. Which direction is that going to go? To the left. Now notice there is no overlap here. So, and word said or. So if it's true for one of them, then it's true for all, like it's not true for both of them. It just means that the acceptable answers could be here or over here. So I'm going to leave both lines there. I'm not going to erase anything because either one of those answers is acceptable because they put the word or.
So there's not going to be conjunction in them like all the time.
Right, they may not use the words conjunction or disjunction. They might use the words and or. Like in this case, they didn't say and or. They just said that it was like it has to be between those two numbers. Well, it's got to be true for both of them there. Like x is a number between 5 and negative 1. So we're going to see it lots of different ways here. One more, we'll do C, and then I'll leave you with the rest of the time to work on your homework. Yes, ma'am?
Can I see
This one?
Yeah.
Okay. Okay, last but not least, go on to C here, and then we'll save the rest for Monday. Notice that we've got two symbols here. Bless you. We've got one here, and we've got one here. And we've got x's in the middle there. We're going to keep those x's in the middle, but we want to isolate them, get them all by themselves, so let's do that. What's my first step? Let's subtract 5 from both sides. Minus 5. Not both sides, rather all sides. Minus 5. Minus 5. Negative 2 minus 5 is negative 7, which is less than 3x, which is less than 20 minus 5? 15. Okay, I can tell already we're going to end up with a fraction. That's okay. What is my next step? I want x by itself. Divide by 3. Divide by 3. Divide by 3. So I've got negative 7/3 is less than x, which is less than 15 divided by 3? 5. Now we're going to graph this in two parts when we do it. Now I think the easier part to do is the part that is not the fraction. You probably agree, but I will not force you into saying that. If you think the other part is easier, that's okay. 4, 5, let's do negative 1, negative 2, negative 3, negative 4, negative 5. So what I'm going to do first is this part right here. X is less than 5. How would I graph just that part? Beautiful. So I'm graphing all the numbers to the left. Notice I take my line all the way across because if there's an overlap, I want to see all of that overlap. Now the other part is kind of ugly here. It looks like this. Negative 7/3 is less than x. Again, why does my soul get on fire when I see that? Yeah, it's not that you can't do it that way. It's just that it's so much easier to interpret when it's over here. I know that x is greater than negative 7/3. And if you're like, but bro, I don't know what negative 7/3 is, don't worry. Let's just figure it out real quick. How many times does 3 go into 7? That's 2. 2 times 3 is 6, with the remainder 1. This is the same thing as negative 2 and 1/3. If you haven't done this in a while, here's my whole number. Here's my numerator. Here's my denominator. That's where I'm getting those numbers from, negative 2 and 1/3. So x is greater than negative 2 and 1/3. Okay, I don't need exact science here, but we should have an idea of where negative 2 and 1/3 is. It's going to be in this area between negative 2 and negative 3, probably closer to 2. So I'm going to put, was it an open circle or a closed circle? I'm honestly asking, I don't remember. Open? Okay. So there's our circle there for negative 2 and 1/3. Am I going to graph to the right or the left of that? To the right, because x is greater than negative 2 and 1/3, so that's all of this area over here. Now, if you notice, there is an overlap. That's what we're looking for, because x should be a number that is between negative 7/3, aka negative 2 1/3, and less than 5. So what I'm going to do is I'm just going to erase that extra area. I don't want that extra area. So not this, and not this.
So on our homework, you want us to do that?
Yes, or if you feel like on your homework that's way too much work, it's taking you a long time, all I ask then is if you're not going to do that, then I'll show you what to do. Like at the very least, if you're not going to erase that, then take a highlighter and show me exactly where your answer is in there. I'm okay with that, but make it perfectly clear to me that you understand that the other junk is not part of the answer. The highlighted part is part of the answer. So I'm okay with that. Now on the test, you won't be able to do that. You're not going to be able to highlight like that. So you're just going to go and you're going to have to erase those extra lines there. Yes, ma'am?
Homework, if let's say it's a fact, you just write conjunction as an answer.
No, so it's going to ask you to solve it and then graph it. So that's exactly what we did. Solve it and graph it. So if it tells you it's a conjunction, it means and. Where do they overlap? If it's a disjunction, it means where either one of them. Like, for example, let me just go and show you something. This is not part of the answer here. If this were a disjunction, I'm going to draw those blue lines that were in there a minute ago that I erased. If I asked you for the disjunction for this answer, it means anywhere where this is filled in would be an acceptable answer here. So anything on the blue line and anything on the red line, which means all numbers there, every single number would be included. So the difference between a conjunction is, the conjunction is just where they overlap. The disjunction is anywhere where the line is going, anywhere at all. All right.